Number 29, we have 3 plus 4i times 3 minus 4i. A plus b times a minus b is a squared minus b squared. And so we got 9 minus 16i squared. 16i squared, that's negative 16. Minus a negative 16 is plus 16. Alright, so that's 25. (31). We've got 6 minus a 2i over 3. So that equals 6 over 3 minus 2i over 3, or 2/3 I. 6 over 3 is 2, so you have 2 minus 2/3 I. Okay, that's it. Number 33, we have 6 plus 4i over I. What you do first is you multiply by the conjugate of 0 plus I, which is 0 minus I, or just minus I. Alright, minus I over minus I. Multiply top and bottom by minus I. Alright. So, oh, I suppose I should put an equal sign and then do it right, huh? This is kind of sloppy here. Alright, so you got this starting with that, and then you've got 6 plus 4i over I times negative I over negative I. So the conjugate of I is negative I. So this is negative I times 6 plus 4i, so you get negative I times 6 is negative 6i. Negative I times 4i, that's going to be negative 4i squared, right? And I squared is negative 1, so it's negative 4 times negative 1, which is positive 4. Alright. I times negative I is negative I squared, or negative of negative 1, which is positive 1. So we can ignore that 1 in the denominator and write it in standard form, 4 minus 6i. That's our answer in standard form. Alright? Okay. Number 35. We have 3 plus 4i over 2 minus I. So what we do is we multiply the top and bottom, numerator and denominator, by the conjugate of the denominator. Which happens to be 2 plus I. So you're multiplying by 1, but that is 2 plus I over 2 plus I. So what we have here is 3 times 2 is 6. 3 times I is 3i. Then 4i times 2 is 8i. And then 4i times I is 4i squared, which is, well, I squared is negative 1, so it's 4 times negative 1, which is negative 4, or minus 4. And then a minus b times a plus b is a squared minus b squared, or 2 squared minus I squared. So we've got 6 minus 4 is 2. on top here. And 3i plus 8i is 11i. 2 plus 11i in the numerator. And here we've got 4 minus I squared, which is negative 1. 4 minus a negative 1 is 4 plus 1, which is 5. So that would be 2/5 plus 11/5 times I. Number 37. Square root of negative 9 plus 3 times the square root of negative 16. So that equals, under the radical you can write a 9 times negative 1, that's your negative 9, plus 3 times square root of 16 times negative 1. And since we're multiplying under the radical, you can split up the radical. So you've got square root of 9 times square root of negative 1 plus 3 square root of 16 square root of negative 1. Alright. So this is square root of 9 is 3. Square root of negative 1 is I, by definition. Then you've got 3 times the square root of 16, which is 4. And then square root of negative 1 again is I. So this is 3i plus 12i, which is, of course, 15i. Number 39. 2 plus square root of negative 12 divided by 2. So what I'm going to do is simplify the numerator first. That's 2 plus square root of 12 times negative 1 under the radical over 2, which is 2 plus square root of, well, I should erase this a little bit, it's a little bit too long. Okay, so that's 2 times, or 2 plus the square root of 12 times square root of negative 1 all over 2. And so that's 2 plus square root of 12 is square root of 4 times 3. And this square root of negative 1 is I. And so that's all over 2. And that's 2 plus square root of 4 times square root of 3 times I all over 2. And that's 2 plus, this is 2, square root of 4 is 2, square root of 3, I, over 2. And now you can factor a common factor of 2 from these two terms here, which I'm doing now, and that leaves me with a 1 plus square root of 3i, all over 2. And now you can cancel the 2's, so you end up with just 1 plus square root of 3i. Number 41. We have I to the 8th, I to the 8th power. Simplify that. There's more than one way to do these. Here's how I did it. I wrote that as I squared to the 4th. raising a power to the power. Remember that? A to the m raised to the n equals a to the m times n. Alright? That's the property we're using here. Okay? That's a little bit different from a to the m times a to the n, which equals a to the m plus n. So that's a little bit different. Alright? So we're using the first rule. So I squared is -1 to the fourth. Now the fourth is an even power. So that is going to become +1. Alright? Anything negative raised to an even power becomes positive. Okay, so that's, just write it out and see. -1, -1, -1, -1. That's equal to +1. And there you go. Number 43, we have I to the 22nd power. So this is I squared to the 11th. And I squared, of course, is -1. So that's -1 to the 11th, which is an odd power. So that becomes still -1. So when you raise that negative to an odd power, the result will be a negative. Number 45, it says for the following exercises, use a calculator to help answer the questions. Okay, I've got mine ready right here, my trusty HP 28S calculator from the 1980s. I love it. So we want to evaluate 1 minus I to the k power. Where k equals 2, 6, and 10. And then it says predict the value of k equals 14. Okay, so I punched it into my calculator and I came up with these. You can do the same with your calculator. If k equals 2, that's answer is -2i. That's what your calculator should tell you anyway. And if k equals 6, answer is 8i. And if k equals 10, you should get -32i. Now if k equals 14, let's see if we can do this by hand, shall we? It's easy enough to do on your calculator, I know, but let's try this one by hand. We've got 1 minus I to the 14 power, and that equals 1 minus I squared to the 7 power. 1 minus I quantity squared to the 7th power, like that. And that's equal to, well, we already know what 1 minus I quantity squared is. That's when k equals 2. So that's -2i, save us a little work there, to the 7th power. Alright? And that's equal to -2 to the 7 times I to the 7. Alright? So this is equal to, you can use a calculator with this, negative if you want, -2 to the 7th is -128. And I to the 7th is I squared cubed times I. So that's -128. and that's I squared is negative 1 cubed times I, and so you get negative 128. Negative 1 cubed is still negative 1, so that's still a negative 1 times I, which is negative I, and negative times negative is positive, so that's positive 128I. Number 47, show that a solution of x to the 6th plus 1 equals 0 is square root of 3 over 2 plus 1/2 I. Okay, so what you can do if you use a calculator is show that square root of 3 over 2 plus 1/2 I to the 6th power, show that that equals negative 1, and then basically you've proved that it's a solution of x to the 6th plus 1 equals 0, because if this does equal negative 1, when you plug it in here, you're going to get negative 1 plus 1, which happens to equal 0. Alright, so that's how you would do it on your calculator. You just have to enter these numbers into your calculator. Alright? But, you know, this is pre-calculus, and we're supposed to be practicing a lot of algebra in this class, because, trust me, there's a lot of algebra in calculus. Alright? So you have to be fluent in algebra if you want to succeed in calculus. In fact, I would say the algebra is more time-consuming and difficult, if you want to put it that way, than the calculus itself. The ideas in calculus are really pretty simple if you think about them, but it's the execution which involves a lot of algebra. Algebra is the gateway to all of higher mathematics and the sciences, so it pays to be fluent in this language. Alright, so let's try this one by hand, see what happens. Okay, this is going to take a little time, and I imagine I'm going to have to erase and give myself more space as I go through here. So bear with me, buckle up. Alright, see if you can follow along. Do it yourself if you can. So we've got square root of 3 over 2 plus 1/2 I. I want to raise that to the 6th power and then add 1 and see what that equals. Alright, so what I'm doing is I'm plugging this into x on the left side of that equation, and then I'm going to see what that thing equals. Hopefully it equals 0. Alright, so that equals, well, the 6th power, let's try square root of 3 over 2 plus 1/2 I squared to the 3rd, like that. Alright, plus 1. And I think I'm going to move this equals sign over here to give myself some space. Equals. Alright, so a plus b squared is a squared, so that would be square root of 3 over 2 squared plus 2ab. Alright, so plus 2. A would be square root of 3 over 2. B would be 1/2 I. Plus b squared. Alright, that's plus 1/2 I squared. And we just squared this part here. We just did this part in the parentheses. That still leaves us with a cubed on the outside, so that's why I put the brackets there. So that close the bracket and put a cube there. Alright. So now we've got plus 1 at the end. Okay. So now let's work inside the brackets. Simplify. So this is square root of 3 over 2 squared, alright? So that's square root of 3 squared over 2 squared. Okay? That's using this property, a over b squared equals a squared over b squared, or you can put whatever power you want there, alright? Works the same way. So that's square root of 3 squared is 3. Now I still have this brackets with a cube. I'm going to change the brackets to parentheses. They're all grouping symbols anyway, because I'm going to be done using parentheses after I simplify this. So I'll just go back to parentheses. So that's going to be square root of 3 squared is 3. 2 squared is 4. So you got 3/4. And then you've got 2 times this times this. Alright, so that's 2 times the square root of 3 times 1, which is 2 times the square root of 3 over 2 times 2. Well, now wait a minute, you can cancel like that. The 2 with one of those 2's. Alright, so that leaves you with square root of 3 times 1 just over 2i, right? So that's plus square root of 3 times 1 is just square root of 3, and then over 2i. Alright? Okay. And now we go to this one. 1/2 squared times I squared. 1/2 squared is 1/4. 1/2 times 1/2. And then I squared is -1, so that becomes minus 1/4. And then everything's cubed in there. Plus 1. Okay, so we can simplify a little bit more. 3/4 minus 1/4 is 2/4, which is 1/2. So you got 1/2 plus square root of 3 over 2i. And that's cubed plus a 1. Alright? Okay, so what is the cube? You can, you might already know a plus b to the cubed or to the third power. There's a formula for that. You may not use it very often, so you may have forgotten it. Or you can, if you've forgotten it, you can do this. You can write 1/2 plus square root of 3 over 2i squared times 1/2 plus square root of 3 over 2i. And then you got the plus 1. Alright? So that's equivalent to that. And what is this? You've got, when you square this, you've got a plus b squared is a squared. So that's 1/4. That's 1/2 squared is 1/4. Plus 2ab. So there's 2, a is 1/2. b is square root of 3 over 2i. And then plus b squared, that would be plus square root of 3 over 2i squared. And didn't we already do that? That's minus 3/4, I believe, right? Minus 3/4. Okay. Because when you square that, you're going to get 3/4 I squared, which is -1, so it's minus a 3/4. Okay, so then we've got the other factor, 1/2 plus square root of 3 over 2i. That's this factor right here. And then plus 1. Alright? Okay, now I'm going to have to make some more room here and erase this. But there you go. You can write that down if you wish. So let me erase. Okay, back to the math. Alright, so what we can do now is simplify. We've got 1/4 minus 3/4, so that equals -1/2. And then we've got plus square root of 3/2i. Alright, that's the 2 times 1/2 times square root of 3/2i. The 2 will cancel with one of those 2's, just like we did before. And we end up with a square root of 3/2i. Alright, and now we also have 1/2 plus square root of 3/2i. Well, it's pretty close anyway. 1/2, pretty close to this one. 1/2 plus square root of 3/2i. Interesting how all these halves and square root of 3/2i's are showing up. Right? You wouldn't have seen that if you just used your calculator. See, you can see patterns emerging, which you can't see by using technology. Alright. So, you know what we've really got here? If I were to switch these two terms inside this first factor, I would have square root of 3/2i minus 1/2, and switch those two. Square root of 3/2i plus 1/2. A minus b, a plus b, right? So that makes it easier if I rewrite it that way. Okay, using the commutative property of addition inside the parentheses. So let me do that. I've got square root of 3/2i minus 1/2 times square root of 3/2i plus 1/2. So there's your a minus b, a plus b, and then plus 1. Alright. So this is equal to a squared minus b squared, right? A squared minus b squared. So square root of 3/2i squared minus a 1/2 squared plus 1. Okay, so this is equal to square root of 3 squared is 3, 2 squared is 4, so 3/4 I squared is -1, so that's -3/4. And then you've got minus 1/2 squared is 1/4 plus 1. -3/4 minus 1/4 is -4/4 plus 1. -4/4 is equal to -1, of course, so that's -1 plus 1, which equals 0. And lo and behold, it is a solution. We did it by hand too. How about that? Alright, number 49. For the following exercises, evaluate the expressions, writing the result as a simplified complex number. So, what we have is 1/i plus 4/i cubed. So that equals 1/i multiplied by the conjugate of I, right? That's 0 plus I. which is 0 minus I, or just negative I. Okay, so that's multiply top and bottom by the conjugate, negative I over negative I. Alright, and that's, let's see, we've got minus a 4 over I. What happened there? I wrote that as I squared times I, and I squared is negative 1, and I put the negative there, okay, and I still have an I left, so yeah, I have 4 I's, as you can see, but now I have an I left there. Alright, so yeah, that was a bad joke, sorry about that. Okay, so here we've got negative I over I squared, the negative of I squared rather, so that's I times negative I, or negative I squared, which is negative of negative 1, or plus 1. Alright, and so here you've got minus 4 over I rather. Multiply that by the conjugate, I over negative I. So this is negative I, and that becomes a positive 1 in the denominator, alright, and that becomes a minus 4I, so minus a minus 4I, or plus 4I. So that's 4I minus I is 3I. Number 51, we have I to the 7th power times the quantity 1 plus I squared. Alright, so you distribute that I to the 7th power through. I to the 7th times 1 is I to the 7. And then I to the 7 times I squared is I to the 9. And then we've got I to the 7 can be written as an even power of I. Let's make that I to the 4th. And then multiply that by I cubed. So there you go. There's I to the 7. And then plus, we can write that as I to the 4th squared. Writing that again as an even power of I squared, that's I to the 8th times I. There's your I to the 9th. So I to an even power will be positive 1 times I cubed, plus also this is a positive 1 squared I. Alright, so this is I cubed is I squared times I, which is negative I. And then you've got plus I. So you add those two and you get 0. Number 53, we have 2 plus I times 4 minus 2I over 1 plus I. So that equals, we've got, now here's an interesting thing we can do. Factor a 2 out of these two. That'll give us a 2 minus I. And then you've got a 2 plus I. 2 plus I, 2 minus I. A plus B, A minus B, right? So that'll make things a little bit easier when we actually compute what that is. So I'm going to factor a 2 out of these two. Put it off to the side here. I could put it in front. I could put the 2 in front. I could put it in the middle. I could put it at the end. Okay? Because of commutativity of multiplication. But I'm going to put it at the end. So I've got a 2 plus I Factoring the 2 out, you get a 2 minus I. And then there's the 2 I factored out. All over 1 plus I. Now I'm going to multiply by the conjugate of the denominator, 1 minus I then, top and bottom. So you're multiplying by 1. Oops. Multiplying, I'm not there yet, but I want to multiply by 1, not changing the value of that fraction, but I am going to change its form. Alright. So there you go. Okay, so what we have then is 2 plus I times 2 minus I, a squared minus b squared, 2 squared minus I squared, or 4 plus 1, right? Because minus an I squared is minus a minus 1, which is plus 1. So you get 4 plus 1. Alright, then you got that 2 there. Then you got the 1 minus I. And then a plus b, a minus b is a squared minus b squared, which becomes 1 plus 1. And there you go. 4 plus 1 is 5. Okay. And let's see, we got, I'm going to put the 2 in front, and then you got the 5, and then you got the 1 minus I. All over 2. 1 plus 1. Now you can cancel the 2's out. So that leaves you with 5 times the quantity 1 minus I. And then you can distribute that through and you get 5 minus 5I. Number 55. Hey, are we almost done? Whoa, yeah, this is penultimate problem. Haha. Okay, hang on, we're almost there. So we've got a 3 plus I quantity squared over 1 plus 2I, the quantity 1 plus 2I, and that's also squared. Alright, so a plus b squared is a squared, that's 9. Plus 2ab, that's 6I. Plus b squared, which is negative 1. And then again, a squared plus 2ab plus b squared is 1. That's your a squared plus 2ab, that's going to be plus 4I. And then b squared is 4I squared, which is minus 4. So 9 minus 1 is 8, plus 6I, over 1 minus 4 is negative 3, plus 4I. So we've got that. Now what we do is we multiply top and bottom by the conjugate of the denominator. So that would be a negative 3 minus 4I. That's the conjugate of the denominator. Okay, so this times this is negative 24, and 8 times negative 4I is negative 32I, and then 6I times negative 3 is negative 18I, and then 6I times negative 4I is negative 24I squared, or plus 24. And here you've got a negative 3 squared, that's a 9, and then minus a 4I squared, and that's going to be plus 16, 9 plus 16. So negative 24 plus 24 is 0. And we've got negative 32i minus 18i is negative 50i. And then over 9 plus 16 is 25. And 25 goes into negative 50, negative 2 times, so that's negative 2i. All right, number 57, the last problem. So, here we go. 4 plus I over I. Plus 3 minus 4i. Over 1 minus I. Okay, so that's 4 plus I over I. Multiplying by the conjugate of the denominator, that's negative I over negative I. Conjugate would be negative I. And then you got plus 3 minus 4i. Over 1 minus I. Again, multiply by the conjugate of this denominator, which is 1 plus I, so multiply by 1 plus I over 1 plus I. Alright, so this is equal to 1 minus 4i over 1. Right? You've got negative I times I is negative I squared, or negative of negative 1, which is positive 1. Negative I times 4 is minus 4i. Alright? And these two multiplied together gives you positive 1. Alright. So now you've got 3 times 1 is 3. 3 times I is 3i. Negative 4i times 1 is negative 4i. And negative 4i times I is negative 4i squared, which is positive 4. Alright. And this becomes 1 plus 1. When you multiply this times this, right, you're going to get 1 plus 1. We've seen that one before. And so you've got 1 minus 4i, the first one here. And then this simplifies to 7 minus I. Over 2. Alright. So this becomes 1. If you write, you can write this as 7 halves minus 1 half I. Okay, 7 halves minus 1 half I. So you're going to have 1 plus 7 halves, the real part. Just adding the real parts here, 1 and 7 halves. And then the imaginary parts, you can write negative 4i and a negative 1 half I, or put a minus and then parentheses 4 plus 1 half I. So negative 4i, negative 1 half I. I just put the minus in front of parentheses. Alright, so that becomes, this is 2 over 2 plus 7 over 2 is 9 over 2. And then you've got minus, and this becomes 8 over 2 is 4. 8 over 2 is 4. 8 over 2 plus 1 over 2 is, again, 9 over 2. I. So that's it. All right, that is it. So that takes care of the complex numbers section. And we'll be using this, who knows, later on. But anyway, good job, guys. Good job. Thumbs up to you. Pat yourself on the back. Well done. All right, take a break. I'm allowing you to take a break, even if it's only for 30 seconds. All right, take care. We'll see you next time.